I will be discussing factoring special cases. This is part 5 of the factoring series. The first example is what's known as difference of two squares. Difference because a subtraction sign means difference, and two squares or difference of squares is when you can take the first term, all of it, including the variable, and you can take the square root of it, and you can also take the second term and do the same. So what's going to end up happening is your answer when you factor it is going to result in a set of two binomials. So it's going to look like this. And what you're looking for is the square root of 16 is 4 times 4. So we need a pair of something to come out one time. And then if I'm looking at v squared, that's really v times v. So I still have a pair. And what some students forget, you can take the square root of 1. It's 1 times 1, which is another pair. So what's going to end up happening when I put my answer in my binomial square is I'm going to end up with that 4 in v for my first term of each one of my binomials. And then on the other side, if you recall, the square root can give you a plus or a minus answer. So in one of the binomials, I'm going to have plus 1. In the other one, I'm going to have minus 1. So that's going to be my answer for that particular problem. If I multiply it back out, 4v times 4v is 16 squared. 4v times negative 1 is 4v. I'm sorry, negative 4v. And then I would go to the second term and do the exact same thing. 1 times 4v is positive 4v. What you'll notice is I don't have a v anymore because they canceled themselves out. The last check that you want to do is the last term. Let me get rid of some of this stuff first. So the last term of the first binomial times the last term of the next one, which is going to be negative 1. So if you go back to your original problem, that's what you had. You had 16v squared minus 1. If we chose to use another method, which I would not recommend, but I know some people don't like to use different methods. They just want to stick with what they know. We're going to go to the box method, which is also known as the area model. What you would do is you would set up your first term in the first box and the last term in the last box. And since we don't have a middle term, what we're going to try to do is find two factors that when I multiply the a and the c, which is 16 times negative 1, that will actually zero out that middle term. So we know factors of 16 are 1 and 16, 2 and 8, and then 4 times 4. So if I'm looking at any of these numbers, no matter what signs I'm using, I won't be able to zero out that middle term unless the numbers are exactly the same. So I would have to have one positive 4 and one negative 4. And since that's replacing what I would rewrite, so basically if I'm rewriting that original problem, what I'm looking for is this. It helps some people to see it this way. So the first term went in the first box, the last term went in the last box, and I'm trying to find two numbers that will replace this 0v. So we just said that it's plus 4v and minus or negative 4v. So now if I factor out to the left, the greatest common factor of that first row is going to be 4v. And the greatest common factor of the last row is I take the sign that's closest to me, and the only numbers that negative 4 and negative 1 can be divisible by is 1. Now multiplying 4v times what will result in 16v squared? Well, that's going to be 4v. 4v times what will result in 4v? So that's going to be 1. And the sign that's closest to me is the sign that I take, so positive 1. Again, what you notice with the difference of two squares, you're going to have a plus and a minus answer. That's important to know because in this next example, you're going to see something that looks similar, but it's not the same. So you have to pay attention to that. This is known as a perfect square trinomial. So a perfect square trinomial, what I can do is check, and let me just write it down here so I don't mess up that original problem. What I want to do is check my first and my last term. Remember, these are called terms, the terms that are The terms are the parts that are before and after your operation, which is in this case a plus sign. So I want to check for my first term and see if I can take the square root because perfect square. And I want to check my last term and see if I can take the square root. And if I can, then I want to see if I can double the answers to get this middle term. So let's just take it apart. The square root of 25 is 5 times 5. So that's one pair. The square root of n squared is simply n times n. So that's a pair of n's. And if I go to the last term, 16 is 4 times 4. So that's a pair. So what really happened in this first term is I brought out a 5n. In this last term, I brought out a positive 4. And for the middle, what I need to do is multiply both of these together. So 5n times 4 is going to be 20n. I take that 20n and I multiply it times 2. I want to double it. When I double it, it should equal what's shown in the middle. And it does. It equals that positive 40n. So therefore, what I can do is go ahead and set up my binomials because, again, I know I'm going to have two sets of binomials. For the first one, I'm going to have 5n plus 4. And then the second one, I'm also going to have 5n plus 4. I told you in another video that if the sign in front of C is positive, that means that both signs will be whatever the sign in front of B was. So both signs will be positive in this case. Now, another way that you will see this answer written, because they have the exact same signs, and this is why I said pay attention to example 1 versus this one, because in example 1, one was positive and one was negative. But in this case, they're both the same sign. So you can write it in the form that's called binomial squared, where you take one of the binomials and then you just square it. It means the same thing. If you chose to use the box method because you did not pay attention to whether or not this was a perfect square trinomial, you're going to be dealing with larger numbers. So what you would do is take your first term and put it in the first box, your last term in the last box. You multiply those two. That's A times C. What you're looking for are factors that will replace that middle term, which is 40n. So if I don't know, I can go to my calculator, and I've shown you this before, and multiply 25 times 16 is 400. Take that 400, go to y equals, and then you put this information in here. I've shown you how to do this before, so you can go back to the other video to see how to input this. Now you want to go to your table. Second graph. What you are looking for is your middle term, which we said is positive 40. The sign matters. So if I look in my third column, I see positive 40 is shown here. What's in front of positive 40 are my two factors that I would need to put in the box, and they are both positive numbers. So positive 20 times positive 20. So that's what I'm going to put here. Plus 20, and remember, I'm replacing 40n, so I also have to include the variable, plus 20n. So again, if I'm doing it correctly, not only will I multiply to get the 400, I'm going to add to get the 40. Now I want to factor out to the left. And on the first row, what is the largest number that they both have in common? Well, it's going to be 5, and the largest variable they have in common is n. So just based off of this, I can fill out the rest of my box. 5 times what will result in 25n squared? It's going to be 5 times n. 5n times what will result in positive 20n? That's going to be positive 4, the sign that's closest to you. That's what you're working with. And then at the bottom, the second row, I can either try to factor out, or I can ask myself 4 times what will result in positive 16. Well, we already know that it's going to be positive 4. On the outside, you have your factors, which are the same as the answer above. So that's how you do that particular example. Example 3. This is known as the sum of cubes. So what I want to just review with you is the inverse. If I have a cube, the inverse is a cube root. So that's what we're going to attempt to do for both terms. Sum, because addition means sum. The answer is going to be sum. So cube root of this first term, cube root of the second term. Well, I know that 125, if I take the cube root, well, maybe you don't know. You can go back to your calculator, second quit, and then for the cube root, you can go to math and then number 4, and then type in 125. Don't worry about the variable part. Well, it tells you that your answer is going to be 5. So we know that 5 times 5 times 5. So notice 3 times, that's what I'm looking for. The same number or variable 3 times. That means I can take it from under the radical. And for u cubed, what I could do is just take this exponent and divide it by the index. So 3 divided by 3, that's telling me that I'm going to end up with 1u coming out. Or you can just, if you're visual, you can sit there and write out 3 u's. So that's going to be 5u. Bring down the sign, plus. And now the same thing, I could go to my calculator and do cube root of 8, or ask myself what number times itself 3 times is 8. So 2 times 2 is 4, 4 times 2 is 8. 3 times means it comes out 1 time. So with the sum of cubes, this is your first binomial. It's going to be in the form of binomial times trinomial. What you want to do is you want to spell out the word SOAP, which represents what's going to happen with your signs. S stands for same, so it's going to stay the same as what you started with. O stands for opposite, and AP stands for always positive. So I know the opposite is going to be a negative. I can just go ahead and set that up. What I'm going to do is I'm going to take my first term and I'm going to square it. So the entire thing, so that will be 5u squared. 5 is squared and the u is squared. So that's going to be 25u squared. Second thing I'm going to do is multiply both terms. So 5u times positive 2 is 10u, but the sign I've already accounted for is going to be the opposite. So it's going to be a negative there. And that's because we don't have a middle term here. We wanted to get rid of it. So they're going to zero themselves out. And then the last term, I'm going to do what I did with the first one. I'm going to square it. So that means 2 to the second power, which is 4. So this is my answer. Those are the steps that you would use if you are trying to factor sum of cubes. Same concept here as far as the strategy, but it's now called a difference of cubes because there's a minus sign there. So I'm going to use the same strategy. I'm going to take the cube root of both terms. And then if I don't know the cube root, just use the calculator, or I could just keep factoring down 8 times 8. I can factor down 4 times 2 and keep going, so on and so forth. So this is going to be 4 times 4 times 4. So that means 1 4 can come out. And then this is m times m times m, which means 1 m can come out. I bring down the sign. And for 27, 3 times 3 is 9 times another 3 is 27. So this is my binomial, 4m minus 3. Same sign. My trinomial, meaning I'm going to have 3 terms, I'm going to have an opposite sign and I'm going to have always positive. So go ahead and put the plus sign, and opposite sign of what I started with is also a plus sign. What I'm going to do again is square this one. So 4m squared, and there's 2 things in the parentheses, so 2 things have to be squared, 16 and the m. I mean the 4 and the m, so 16m squared. Now I'm going to multiply these 2 terms, 4m times 3. I'm not even worried about the sign because I've already accounted for it. Is going to be 12m, and then I am going to square the last term. And it doesn't matter if you do the -3 or if you just do 3 because it's always positive. So 3 times 3 is 9. Make sure you put that in the calculator. 3 times 3 is not 6, okay? That's a common error. So my final answer is going to be the quantity of 4m minus 3 times the quantity of 16m squared plus 12m plus 9. And you can always double check it by taking your 4m, multiplying it times the 16m squared, you're going to see that you get back to your 64m cubed. And then you can do the same thing for the last part, -3 times +9, and that's going to get you back to the -27. If you were to multiply all of it out, you're going to see that the middle part disappears because they have opposite signs. That was the purpose of us doing opposite signs. Okay, that was it. Thumbs up, subscribe. Have an awesome day.